This video is going to be a tutorial for a multiplication of a 1-digit factor by a 2, 3, or 4-digit factor. For my example problem that I'm going to start with, we have a 1-digit factor of 8 multiplied by a 3-digit factor of 324. Now for this, we are going to use an area model. The reason that we can use an area model is an area model is a rectangular array. And we know that in a rectangular array that our product can be calculated by multiplying our rows times our columns. If we look at this as a rectangle, we know that the area of a rectangle can be calculated by length times width. So if you look at those two, the correlation between them, the area, which is the inside of the rectangle, is the same as our product. The length, which is this side, is the number of rows that we have, and the width is the number of columns that we have across the top. So if we go back to our problem, we know that rows times columns equals our product. So we use our first factor to tell us how many rows that we have, and we place that here. The next factor will go across the top. However, 324 is a 3-digit number, and it's not a number that most people know they're multiples of. So we need to rearrange 324 to a number that better suits our abilities. So if we expand this number, expand means that we break it apart based upon the value of each digit, we will get numbers that we can actually do the multiplication with. So 324 expanded is 300, because you have a 3 in the hundreds place, plus 20, 2 in the tens place, plus 4 in the ones place. That would be 324. We're going to treat each of these separately, okay? So let me repeat that again. You're going to expand the multi-digit number to where it creates numbers that you can easily work with. Now, instead of one large rectangle now, I have 3 individual rectangles. So I'm going to treat these each individually. I'm going to focus on this rectangle first. Rows times columns. If you are multiplying by a multiple of 10 or 100, any number that ends in zeros, you can put the zeros in and then multiply the non-zeros. So 8 times 3 is 24. I'm finished with this rectangle, so I move to this one. Now you can't see the 8 anymore from the video, but I'm going to go back out a little bit. We are using the 8 rows with the 20 here. So 8 times 20, and the product goes in this section. So it's 1 0, and then 8 times 2 is 16. Move on to the next section. Remember, we're still multiplying by 8. 8 times 4, there's not any zeros, so I don't have to put any extra zeros on there. I just do 8 times 4, which is 32. So now I have 3 pieces that create my whole product. These 3 pieces are parts, so we call those partial products. So I now have to take my partial products and put them together with addition so that I can get my product. So over to the side, I take my partial products of 2,400, 2,400, whichever way you want to say it, 160, and 32, and I'm going to add them because I have to put those together in order to get the product of 8 times 324. add my ones place, add my tens place. 6 plus 3 is 9. Hundreds place, 4 plus 1 is 5. Thousands place, 2. So, the product of 8 times 324 is 2,592. All right, so now I have another example ready for us. This time we have a 1-digit factor times a 4-digit factor. I've already broken it down for us because I don't know my 8,463 facts. I wouldn't imagine that anyone would. Our rows times our columns. Remember, product equals rows times columns. Rows times columns. So my rows are 5 and my column is 8,463. I have to expand that, which again means that I take each digit, I break it apart by its value. So 8,460, which is 6 tens and 3 ones. After I expand, I now need to concentrate on each individual rectangle that was created. So let's focus on this one. I have zeros, extra zeros here. I'm multiplying by a multiple of 10 or 100. So that gives me 3 zeros. 5 times 8. This is why I tell my students to put the zeros down first. A lot of students make the assumption, because most of the time this is the case, that if there's 3 zeros up here, there's only 3 zeros in the answer. That is not what that means. This means that I have 3 extra zeros after I multiply the non-zero numbers. Well, 8 times 5 gives me a product that ends in the 0. So 40 is the answer to 8 times 5, and then I have 3 extra zeros. So what I say is multiply the non-zeros and put the zeros at the end. So we multiplied 8 times 5 and then put the 3 extra zeros on. Move to the next spot. We're still multiplying by 5. Once again, I have extra zeros, so I'm going to go ahead and write those in so I don't get myself confused. Because as you see, when I do 5 times 4, I end up with 20. And a lot of kids at this point are going to say, wait a minute, there's 2 zeros. Why is there 3 in here? Because 4 times 5 gave me the 20, and then I put 2 extra zeros on it. Move on down. We're still multiplying by 5. I have a 0 that goes in here. 5 times 6 is 30. So it's 300. Even though there's 1 0 up there, that just means I had 1 extra 0. The product of 6 and 5 was 30, so it's 30 and 1 extra 0, which is 300. The next one, 5 times 3 is 15. No zeros for extra. Zoom back out for you. If you see, those are our partial products. 40,000, 2,315. Remember, those are parts. I want the whole product, the whole area, not just the pieces. So to get the whole area, I have to go back and add my partials. So I'm going to go over here, and I'm going to add 40,000, 2,315. So you start in your ones place. It's very important that you line these up. If you don't line these up, your sum, when you add, is going to be incorrect. So make sure that when you're adding up your partial products that you line up by place value. My tens place, I have 1. Hundreds place, 3. Thousands place, 10,000s place. So my product for 5 times 8,463 is 42,315. Always remember when using an area model for multiplication that you expand the multi-digit number, multiply each section, and then add your partial products to get your final product.